Hey guys, so in the previous video, we talked about graphing sequences and charting and plotting the n values, a of n values, and series values, and doing that all automatically. Now, um, I'm just going to get right to it and tell you, you're not always going to want to make a chart for every problem. Say the problem doesn't tell you to identify a of n from 1 to 10 and s of n from 1 to 10, and they just want the sum of the series from 1 to infinity. Uh, Instead of making the entire chart and having to do that and see where it approaches, or if it even approaches at all, you could just use what I'm about to tell you to do that. So this video will be dedicated to finding the convergence or divergence of a series, and then if it is one or the other, the place where that happens. So let's open a calculator tab, so menu 1, and let's deal with a good old function sequence 1 over 2 to the n. Alright, so we want the sum of the series. So we want the sum of all a of n values from 1 to infinity. So that's going to be sigma. So let's go menu, and we're going to go to calculus 5, which is sum. And look at that, we get a sigma. So we're going to go n equals 1, that's our starting point, and then we're going to go control and the little book, it's like catalog, and you can find the infinity, select it, and hit enter. And we want that on top. And then our function, or our sequence, in the parentheses. 1 over 2 to the n. And if you remember correctly, we should get 1 as our answer. There you go. 1. So this is a pretty basic power sequence. This also works with geometric sequences. But they're not all this easy, you know? Like, sometimes, like with the harmonic that Mr. Miller was talking about, it diverges, but it seems like it's going to converge. So what happens when we plug in the harmonic to this? Will it tell us that it's infinity? Infinity is the correct answer, but will it tell us that? It should, right? Wrong. So the reason that it doesn't tell us is a bit hard to explain, but basically we have asked the calculator to add up an infinitely increasing amount, period. An infinitely increasing amount. Now, we didn't tell it to approach infinity, we told it to go to infinity. And technically speaking, that's impossible. So how can we tell the calculator to go to, not instead of going to infinity, to approach infinity? That's right, approaching, we're talking about limits. So menu 4, and we're going to approach infinity instead of going directly to it. And now we can insert the harmonic, but instead of, now look what happens when we just do the limit. We know that this is going to be 0 because 1 over infinity, that's 0. But think about it like this. Now, the limit of the expression itself, this is basically just telling us that a of n approaches 0, which means that there's a chance, quote unquote, that it could be convergent. We know now that it's divergent based on the video that Mr. Miller told us. But if we didn't know that, right, let's go back, let's have our limit, and instead of putting just the sequence in there, let's put the entire sigma in there and see what happens. Remember that the correct answer is infinity. There you go. There's the correct answer. So what we have basically done here is we've told the calculator that we want it to add up all the numbers between 1 and infinity for n, for 1 over n for the harmonic sequence, And we want that to happen. But we don't need to go all the way to infinity. We can just approach infinity. And that's going to be much more manageable for the calculator. And now it can tell us that it is indeed divergent and it's approaching infinity. Now, don't worry. Don't think that this now only works for divergent functions. We can even plug in old ones that we know to be convergent, like the 1 over 2 to the n. That's still 1. Another example that I saw was n over 5 to the n, which should come out to be, I believe 5/16 was the answer. There you go. Let's try another hard one that doesn't necessarily come out to equal, or that isn't, you can't just use the sigma. So here's sigma. Let's go from n equals 1 to n equals infinity. For, I believe Jacob showed me this one, it was n squared plus n to the 4th. Another, not too complex, but moderately complex power function, or not power, exponential function here. And yeah, so we know that when we hit enter and we get the same thing back, or see it factored out at n squared here, so but generally you get the idea that it's the same function. When it spits the same thing back at you, you can probably assume that it's divergent, but you don't want to do that necessarily. So I think it's much more, maybe a little less practical, but still worth it to do the extra step of going from n to infinity and just taking this in here and making sure that it does indeed go to infinity. Now, a useful tip that I have for you is that just because it seems like a sequence is approaching, or a series is approaching a certain number, it doesn't necessarily mean it. So now, obviously, if you have a series that's like 0.5, then 0.75, then 0.875, then 0.9, then 0.999, and then 0.99999 in only like 6 n steps, obviously you can tell that that one is going to go to 1. But when you start at like 1 and then you go gradually downwards to like 0.5678, which I think this one approaches that value, when you get a series that's like a weird number like that, you might not be certain that it's actually converging. So I think this calculator feature is very useful in checking whether the series actually converges or if it diverges. And it should work 100% of the time as long as you input your sequence correctly and make sure you understand the formatting for the sigma and limit usage. Remember, you do not need to have a boundary for your limit, so do not worry about saying whether it's from the left or the right. We simply just want n to approach infinity. So yeah, that is pretty basic coverage of this topic and this feature on the calculator. It's very useful. I recommend, again, that you use it to check your results from what I've shown you in the previous videos. So if you have a series and you're not really sure about it, I would definitely use this to check. So yeah, that's pretty much it for this. If you have any questions, you're free to ask me. All right, bye-bye.